Hello everybody, welcome into another lesson. So today we are going to talk about rational functions. In the next lesson we will graph rational functions, but today we're just going to talk about them. So again, this may largely seem like a review from Algebra 2, where rational functions are ones that the problem is with them, you can have values for which the function's undefined. That value for which the function is undefined is going to be when the denominator is 0. Right here you have the classic example of the mother rational function, f of x equals 1 over x. Well, if we take a look here, if x equals 0, you would get an undefined value, right? X can equal anything else except for 0. So we can say that the domain is going to be from negative infinity up to 0, non-inclusive. It can't be 0. And then in union with 0, non-inclusive to infinity. So your domain can be anything literally except for 0. Alright, so what does that say about our range? The range, on the other hand, so let's say I put in values infinitely close to 0. Let's start there. Infinitely close to 0 from the left. If I put in 1 over negative 1/2, for example, I'll get negative 2. If I put in 1 over negative 1/4, I get negative 1/4. If I put in negative 1/1,000,000th for x, I would get negative 1,000,000. So my range would be from negative infinity up to, let's put in a very high negative value. If I put in, well, let's just start with like negative 4. If x is negative 4, for example, it's just going to be negative 1/4. If x is negative 250, it'll be negative 1 250ths. Put in negative 1,000,000, it'll be negative 1,000,000th. It gets infinitely closer and closer to 0 for a y value, but it never actually reaches it. So my range is actually the same in this case. It's from negative infinity to 0 non-inclusive. And then if we apply this to the right of 0, you get infinitely closer to 0 from the right. You'll go to infinity, and then you keep putting in bigger values of x. You'll get infinitely closer to 0, but you won't actually reach it. So the range is actually the same thing. Negative infinity to 0 in union with 0 to infinity. That's for your normal function. Now, when you have other shifts or things like that, that's where these may vary slightly. But also, it's worth mentioning, whenever the denominator equals 0, that's what's called a vertical asymptote. So x equals 0 is your vertical asymptote. That's going to occur whenever the denominator would equal 0. X equals 0 is your vertical asymptote. Now, so that means, like, graphically, your x value could get infinitely closer and closer to 0, but it would never actually touch it, because if it touched x equals 0, that would give you an undefined value. There's also a horizontal asymptote, which deals with our range. Notice in the range, the y value gets infinitely closer and closer to 0 without actually reaching it. So you also have a horizontal asymptote at y equals 0. In fact, here's the thing with horizontal asymptotes. If the degree of the numerator is less than the degree of the denominator, it'll always have y equals 0 as a default horizontal asymptote. because that 1 is the same as x to the 0, which would just give you 1. It's definitely less than x to the first, so whenever the degree of the numerator is less than the degree of the denominator, y equals 0 is your horizontal asymptote. Now, we'll get into other types of rational functions today where that's going to vary a bit. But also, we want to talk about intercepts. Well, you have a y-intercept whenever x equals 0, but if you put in x equals 0, it's undefined. So there is no y-intercept. There is no y-intercept. And then, as you know, when y equals 0, you have an x-intercept. Well, that would be the same as saying 1 over x equals 0. If you cross multiply, you'd be saying 0 equals 1, which it certainly doesn't. That would be undefined. So there's also no x-intercept in this case. So there's actually no intercepts for this. So let's get into some rational functions. We're going to start with when the degree of the numerator is less than that of the denominator. Alright, so let's do this one here. We have f of x equals 1 over x minus 1. F of x equals 1 over x minus 1. Well, we can for sure say that this is a shift 1 unit right for f of x equals 1 over x, so that's a horizontal shift 1 unit right from the normal f of x equals 1 over x. Now, we also got to consider the domain. If you take x minus 1, set it equal to 0, you would get x equals 1. Well, when x equals 1, you're going to actually have an undefined value. So your domain goes from negative infinity to 1 non-inclusive in union with 1 to infinity non-inclusive. So you can have any value except for x equals 1. Now your range, again, you're going to go from negative infinity to 0. This will still get infinitely closer and closer to 0 without actually reaching it. So the range is going to be from negative infinity to 0 non-inclusive in union with 0 to infinity non-inclusive. So now we could talk about a vertical asymptote. That always occurs when the denominator equals 0. So x equals 1 is your vertical asymptote. And since the degree of the numerator is less than that of the denominator, y equals 0 is your horizontal asymptote. Now let's talk about intercepts. Again, y-intercept occurs when x equals 0. X can be 0 this time. If we put in 0, you get a y value of negative 1. So the y-intercept is actually located at 0, negative 1. We do have one y-intercept, but what about an x-intercept? Well, if you set 1 over x minus 1 equal to 0, you're just going to end up then getting 0 equals 1, which we know isn't true, so there's no x-intercept. So this also can tie into when we talked about stretching, shifting, and reflecting graphs as well. Because you have a horizontal shift to the right 1 unit. Alright, let's continue some more here. f of x equals 2 over x plus 2. So we have f of x equals 2 over x plus 2. Okay. Well, we definitely have a stretching factor of 2, right? So you're stretching the original f of x equals 1 over x by 2, so it's stretched by a factor of 2. What else do we notice from the original rational function? You have x plus 2, so that means you have a horizontal shift left 2 units. So you're shifting left 2 units. Alright, so now we need to deal with the domain. If we set the denominator equal to 0, x plus 2, you would get x equals negative 2. So that means you can have this, you can accept any value of x except for negative 2, which would make this undefined. So the domain is going to be from negative infinity to negative 2 non-inclusive in union with negative 2 non-inclusive to infinity. Now what about your range? Your range, once again, it's going to get infinitely closer and closer to 0. However, it'll never reach it. So your range would still stay from negative infinity to 0 non-inclusive in union with 0 to infinity non-inclusive. So let's talk about asymptotes. That occurs when the denominator equals 0. So x equals negative 2 is going to be your vertical asymptote. And then, since the degree of the numerator is less than that of the denominator, then you have a default horizontal asymptote at y equals 0. Alright, so now what about when, let's find y-intercepts. So x is able to equal 0. If we put in 0 for x, you'll get a y value of 1. So you have a y-intercept which occurs at 0, 1. But what about x-intercepts? You're not going to have one, right? Because you would end up getting 0 equals 2, which isn't true. So there are no x-intercepts. So that's the deal with f of x equals 2 over x plus 2. Alright. How about one like this? F of x equals 1 over x squared. So f of x equals 1 over x squared. Well, this is pretty much a rational function, only you're squaring the x. So let's talk about your domain. What value of x would make this undefined? It would just be 0 again, right? You could have any value except for 0. So you'll end up getting negative infinity to 0 non-inclusive in union with 0 to infinity non-inclusive. But here's where it gets interesting. This is 1 over x squared. So your range is going to be a little bit different. Whether your x is positive or negative, you're going to get a positive y value, aren't you? So your range is going to get infinitely closer and closer to 0. The smaller value you put in, like if I put in 1/4, I would get 1 over 1/16, which would give me infinity. Okay, so either way, whether it's positive or negative, I'll go to infinity. But let's say I put in 1 over 16, that'd be 1 over 256. Or 1 over negative 16, that'd still be 1 over 256. I would get infinitely closer and closer to 0 without actually reaching it, whether my x is positive or negative. So my range is only from 0 non-inclusive to infinity. You're only going to have positive values in your range. Now, the vertical asymptote would still occur when x equals 0. X equals 0 is your vertical asymptote. Now, of course, the degree of the numerator is less than that of the denominator, so y equals 0 is your horizontal asymptote. Okay, so then we need to talk about intercepts. Y-intercept occurs when x equals 0, but that would make this undefined. So there are no y-intercepts in this case. What about an x-intercept? Well, that'd be saying 0 equals 1, which isn't true, so there are no x-intercepts in this case either. So there are no intercepts in this case. All right, one more of this type. Then we're going to do some other types of shifts. All right, we have f of x equals 3 all over the quantity of x minus 2 squared. So we have f of x equals 3 over x minus 2 squared. Well, let's look at this here. What value of x would make this undefined? Set that x minus 2 equal to 0, you get x equals 2. So the domain can literally be any value of x you want it to be except for x equals 2. So the domain goes from negative infinity to 2 non-inclusive in union with 2 to infinity non-inclusive. All right. Now what about your range? Again, whether you put in positive or negative values, you get a positive or negative denominator, it's always going to end up positive. So your range, you'll only have positive values since it's a square in the denominator. So your range would be from 0 to infinity, 0 non-inclusive. All right, well, we still have vertical asymptotes. That's going to be when x equals 2. You would have a vertical asymptote. Now, what about the horizontal asymptote? The degree of the numerator is less than that of the denominator, so you'll have a horizontal asymptote at y equals 0. Now, what about intercepts? You have a y-intercept when x equals 0. If you put in 0 for x, you would get negative 2 to the second, which would be 4. You get a y value of 3/4. So the y-intercept would occur at the point 0 3/4. Now what about the x-intercept? Well, that's when y equals 0. You would end up literally getting 0 equals 3, which is not a true statement. So there are no x-intercepts. So that's the summary for this one. All right, let's do some other types of shifting, and then we'll go on to different degrees. Let's say we had f of x equals 4 minus 1 over x. So suddenly this has changed. F of x equals 4 minus 1 over x. Well, we definitely still want to deal with the domain. What value would make this function undefined? What value of x? That would be when x equals 0, right? So your domain hasn't changed. That's going to end up being from negative infinity to 0 non-inclusive in union with 0 non-inclusive to infinity. All right, now what about when we want to deal with the range? we can clearly see that negative 1 over x is just a reflection in the x-axis, and the y-axis for that matter too. This is simply a reflected graph. And then that 4 is like a plus 4. So this would end up being a vertical shift upward 4 units. So we could definitely say this is reflected in both axes. And then you have a vertical shift up 4. Well, the normal negative 1 over x, you would have a horizontal asymptote at y equals 0, right? But you're adding 4. Whenever you do a vertical shift, that actually shifts your horizontal asymptote as well. Which means that you're going to get infinitely closer and closer to y equals 4, but you're never actually going to reach it. So your range is actually going to be from negative infinity to 4 non-inclusive, in union with 4 non-inclusive to infinity. Alright, so now we've established that we have a vertical asymptote at x equals 0. We have a horizontal asymptote at y equals 4 because that plus 4 shifts everything upwards 4 units. Alright, let's talk about intercepts. This is going to get very interesting. Well, y-intercept when x equals 0 won't exist in this case. There are no y-intercepts. However, let's look at x-intercepts. So 4 minus 1 over x equals 0. That would be the same as 1 over x equals 4, which would end up giving you 4x equals 1. X would equal 1/4. So you actually do have an x-intercept at the point 1/4, 0. That's your only x-intercept, is going to be at 1/4, 0. And x being 1/4 does not violate the domain, so that works. Let's do one more like this, and then we'll move on to when the numerator and denominator are the same degree. F of x equals 2 plus 1 all over x plus 3. So f of x equals 2 plus 1 all over x plus 3. Well, let's just start with the original function. It's here. What is transformed from the original function? That 1 over x plus 3, you have a horizontal shift left 3, right? So you have a horizontal shift left 3 units. Then that 2, that plus 2, you also have a vertical shift up 2 units. Which is going to shift your vertical asymptote and your range. Alright, now, let's look at the domain. Again, that's for any value of x that would not make this undefined. If you set x plus 3 equal to 0, you would get x equals negative 3. That's the only place where the function's undefined, at x equals negative 3. So your domain goes from negative infinity to negative 3 non-inclusive, in union with negative 3 non-inclusive to infinity. So you can have any value of x you want except for negative 3. Now, what about your range? Well, normally you would just get infinitely closer and closer to 0, but since you've shifted everything up 2 units, your range is actually going to go all the way up to 2. So your range would end up being from negative infinity to 2 inclusive in union with 2 to infinity inclusive. Negative infinity to 2 non-inclusive in union with 2 non-inclusive to infinity. Okay. Asymptotes. So x equals negative 3, of course, is the vertical asymptote. Now, normally if it was just 1 over x plus 3, you would have a horizontal asymptote at y equals 0, but that plus 2 makes y equals 2 to be your horizontal asymptote. Now let's look at intercepts. We do have a y-intercept because if x equals 0, you get 1/3 plus 2, you would end up getting 7/3. So you have a y-intercept at the point 0, 7/3. You'll even have an x-intercept. So if you set 1 over x plus 3 equal to negative 2, you would end up getting negative 2x minus 6 equals 1. That would end up giving you negative 2x equals 7. X would have to equal negative 7/2. So you end up getting an x-intercept even at the point negative 7/2, 0. So this time you actually have an x and y intercept. All right, let's go on to now when the degree is the same. F of x equals 5x all over x minus 1. So observe this time that the degree of the numerator and the denominator are to the same degree. Well, we want to establish the domain first. The domain, or actually let's work with our asymptotes first. The vertical asymptote occurs whenever, again, it's still the same in this part, whenever the denominator would equal 0. That would be when x equals 1. So x equals 1 is your vertical asymptote. All right, so now, what about when you have, when you want to look at horizontal asymptotes? That's going to be whenever you have the degree of the numerator the exact same as the degree of the denominator. In this case, they're both to the first power. You just divide the leading coefficients. So take 5 divided by 1, you would get y equals 5. So y equals 5 is your horizontal asymptote. All right, now your domain. The domain, again, is all real numbers except x equals 1. So the domain would be from negative infinity to 1 non-inclusive in union with 1 non-inclusive to infinity. Now your range is going to definitely go to 5. So that's going to end up then being, for your range, you put in any negative values here. When you put in 0, you get 0. 1's undefined. Let's say we put in x equals 2. You would get 10 divided by 1, which is 10. So you would end up going for sure from 5 to infinity. It would get infinitely closer to y equals 5. But let's look at some negative values of x. You would end up getting, for -1, you would get -5 divided by -2. Well, that'd be positive again. If you put in -3, you would end up getting -15 divided by -4. That'd be -15/4. So you're going to get infinitely closer and closer to, you get positive 15/4, excuse me. So you'll get infinitely closer and closer to 5 without actually reaching it. So your range in this case is going to be from 5, non-inclusive, to infinity. You literally will not get you will not end up getting any negative values, truly. Actually, you would, because you'd have 5 halves over negative halves. Let's put in x equals a half. So 5 halves over -1/2 would equal 5 halves times -2. That would give you -5. So you can get negative values. Your range is going to be from -infinity to that horizontal asymptote of 5, non-inclusive, in union with 5, non-inclusive, to infinity. There we go. We always have to remember those intermediate values between 0 and 1, and all those fractional values, where for a brief moment you can have negative values. Alright, let's talk about intercepts. So y-intercept occurs when x equals 0. Well, you would have a y-intercept at 0, 0 in this case. What about x-intercepts? So that would be when 5x over x minus 1 equals 0, which would just give you 5x equals 0, x equals 0. So your x-intercept is also at the origin. And that x equals 0 does not violate your domain. So it just shifts your asymptotes a little bit when you have them to the same degree. We'll do some more with the same degree, then we'll go on to when the numerator's higher than the denominator. Alright, f of x equals 4x plus 1 over x. F of x equals 4x plus 1 over x. Well, that of course is going to be, let's look at the asymptotes. The vertical asymptote occurs when x equals 0. Literally, it's going to be when the denominator equals 0. So we have a vertical asymptote at x equals 0. Now what about your horizontal asymptote? The degree of the numerator is the exact same as the degree of the denominator, so take your leading coefficients, take 4 divided by 1, you would get y equals 4. So you are given a horizontal asymptote at y equals 4. Okay. Now we could talk about your domain. Your domain can be literally anything except x equals 0. So the domain is from -infinity to 0 non-inclusive in union with 0 to infinity non-inclusive. Now if you have a horizontal asymptote at y equals 4, that means your range would go from -infinity to 4 non-inclusive in union with 4 non-inclusive to infinity. So you'll get infinitely closer and closer to a y value of 4, but you'll never actually reach it. Now let's talk about intercepts. Y-intercept would occur when x is 0, but that would make this equation undefined. So we can soundly say we have no y-intercept. Can't say the same for x-intercepts. If you take 4x plus 1 over x, set it equal to 0, you would end up getting 4x plus 1 equals 0, which would give you 4x equals negative 1, and then x would equal negative 1/4. So you actually do have an x-intercept at the point negative 1/4, 0. And that x equals negative 1/4 does not violate your domain, so you're good. Let's do one more of the same degree, then we'll go on to higher degrees. Actually, let's do a couple more of the same degree. Let's say we had f of x equals x times x plus 2 all over (2x minus x squared). Well, let's look at this here. So you're definitely going to be able to cancel some things out. Now, you want to keep the original in mind. Wouldn't this be the same as, we're going to expand out the numerator, but we're going to leave it this way too. There's a reason for that. Your numerator would be the same as x squared plus 2x. This is going to help us when we go to figure out our asymptotes. So x squared plus 2x all over 2x minus x squared. Alright. Well, the degree of the numerator is the same as the degree of the denominator. That, of course, is going to be negative 1 over negative 1. Since they're both of the second degree, it would look like we have horizontal asymptotes, but you can cancel out certain things. So let's simplify the denominator. You would have x over x plus 2 all over x times 2 minus x. Well, notice your x's cancel out. So this would in fact simplify into x plus 2 over 2 minus x, which in fact would give you a horizontal asymptote at y equals negative 1. That much is true. Now, there's a couple things we gotta talk about with this. If you look at your factored form, set 2 minus x equal to 0, what do you get? You would get that x equals 2. You would in fact have a vertical asymptote at x equals 2. That much is correct. But there's a very important piece that we're missing with this. You have to defer to the original. You can even defer to the original factored form before you canceled out the x's. Though the x's divided out, you don't have a full-fledged asymptote at x equals 0. You have what's called a discontinuity. You have a hole at x equals 0. It's literally just one piece where it's not defined. So when x equals 0, that's not defined. Though granted, if you put in 0 here, you would get 2 over 2, which would give you a y value of 1. But you have to defer to the original even though it canceled out, since it canceled out, you only have a hole at x equals 0, not a whole-fledged vertical asymptote. So let's look at the domain. The domain, of course, we cannot allow x to equal 0 or 2, so the domain goes from negative infinity to 0 non-inclusive in union with 0 non-inclusive to 2 non-inclusive in union with 2 non-inclusive to infinity, only for the fact that we have a hole at x equals 0. Now your range, of course, you're still going to get infinitely closer and closer to -1. So you'll end up having a range from negative infinity to -1 non-inclusive in union with -1 non-inclusive to infinity. Now what about intercepts? Well, when y equals 0, when x equals 0, you would end up getting normally a y-intercept of 1, but there's a hole at x equals 0, so we have no y-intercept in this case. Now, what about x-intercepts? You can go ahead and set x plus 2 equal to 2 minus x, so x plus 2 equals 2 minus x, which would give you then that 2x equals 0. You would also get that x equals 0. That would be a discontinuity because there's a hole at x equals 0, so there are going to be no x-intercepts in this case. So truly, we have no x-intercepts or y-intercepts. No, wait a minute. I did that wrong. I don't know why I said x plus 2 equal to 2 minus x. I was wishing it equaled 1. You would just get x plus 2 equals 0. You would get x equals -2. So you have an x-intercept at -2, 0. Excuse me for that. You do get an x-intercept at -2, 0. Okay. Let's do another one of these. All right, f of x equals f of x equals x squared minus 25 all over x squared minus 5x. Sorry, x squared minus 25 over x squared plus 5x. Excuse me for that. Alright, well, we can soundly say we can factor the numerator and denominator, right? This would turn into x plus 5 times the quantity of x minus 5 all over x times x plus 5. Well, good news is the x plus 5s are going to cancel out, which is going to simplify this into x minus 5 over x. So let's look at vertical asymptotes. You would definitely have a vertical asymptote at x equals 0, right? Now, how about a horizontal asymptote? Well, the degree of the numerator is the same as the denominator. You would have a horizontal asymptote at y equals 1. Yep, y equals 1 since you take 1 divided by 1. But there's one more matter. We also have a hole. The x plus 5s may have canceled out, but there's still a hole there. because you have to defer to the original equation. So x plus 5 equals 0 would give you a whole at x equals -5. So x equals -5 is not a full-fledged asymptote. There's just a hole where x equals -5. Okay. Now, we need to discuss the domain. The domain, we can accept any values except for x equals -5 or 0. So the domain goes from -infinity to -5 in union with -5 to 0 in union with 0 to infinity. So the only two values of x we cannot accept are -5 and 0. So what about your range? Your range, again, is going to be from, you have a horizontal asymptote at y equals 1, so that'll be from -infinity to 1 in union with 1 to infinity. Now, what about intercepts? This always occurs when y-intercepts occur when x equals 0. Well, you would have an undefined expression when x is 0, so there are no y-intercepts. How about x-intercepts? We can set that x minus 5 equal to 0. You would get x equals +5. Well, it is defined at x equals +5, so you do have an x-intercept at 5, 0. Alright, last but not least, let's move on to when the degree of the numerator is greater than that of the denominator. You find some good examples of that here. F of x equals x squared minus 4 all over x plus 3. Alright, so all of a sudden we have a rational function in which the degree of the numerator is actually greater than the degree of the denominator. Well, let's deal with our vertical asymptote. You're going to have a vertical asymptote. That much hasn't changed. That, again, is when the denominator equals 0. So you for sure have a vertical asymptote when x equals -3. Now, what do we do for horizontal asymptotes? Okay, when the degree of the numerator is greater than the degree of the denominator, there are no horizontal asymptotes. There is no horizontal asymptote. However, if the degree of the numerator is greater than the degree of the denominator by only 1 degree, in this case it is, you have what's called a slant asymptote. That is found by taking the numerator, using long division, taking the numerator and dividing the denominator, so you would get x squared plus 0x minus 4 divided by x plus 3. Alright, so x goes into x squared x times, so you would end up getting x squared plus 3x. Alright, so subtract, let's see, 0, you would get -3x minus 4. X goes into -3x, -3 times, so you would end up getting -3x minus 9, so subtract, you would end up just having a remainder of 5. Alright, so you have what's called a slant asymptote. You do the long division, you ignore the remainder. You only care about what you got besides the remainder. So you're going to have a slant asymptote at y equals x minus 3. And that only occurs when the degree of the numerator is greater than the degree of the denominator by 1 degree. If it's any more than 1 degree, you don't even have a slant asymptote. You would have at most a vertical asymptote, nothing else. Okay, so let's consider the domain. The domain is going to be, again, x just can't equal negative 3. So that would end up being when you got the domain from negative infinity to negative 3 non-inclusive and union with negative 3 to infinity non-inclusive. What about your range? Your range in this case, because you have a slant asymptote, you have no horizontal asymptote, your range is actually the entire set of real numbers. There are no restrictions on the range. You have the entire set of real numbers. Alright, so now what about intercepts? Intercepts occur again, y-intercept when x equals 0, you would get negative 4/3. So you have a y-intercept that occurs at 0, negative 4/3. X-intercepts, well, set all this equal to 0, you just get x squared minus 4 equals 0. You get x equals both plus and minus 2. So you have x-intercepts at both plus and minus 2, 0. Alright. We'll do more with slant asymptotes. Oh, good one. F of x equals x to the third minus 8 all over x squared plus 4. Very good one. So f of x equals x to the third minus 8 all over x squared plus 4. Well, let's look for vertical asymptotes. Well, are there any values of x that would make the denominator undefined? There aren't any, because this is a sum of two squares, so we actually have no vertical asymptote for once. We got no vertical asymptotes. Now, look at the degree of the numerator over the degree of the denominator. The numerator is greater than the degree of the denominator, so we don't have a horizontal asymptote. However, the degree of the numerator is greater than the degree of the denominator by exactly 1 degree. Which is going to mean we do have a slant asymptote. So let's do our long division here. So x to the third plus 0x squared plus 0x minus 8 divided by the x squared plus 0x plus 4. So x squared goes into x cubed x times. You would end up getting x to the third plus 0x squared plus 4x. Do some subtraction here. That'd be 0, 0. You would end up getting negative 4x minus 8. That negative 4x minus 8 is your remainder, so you ignore the remainder. You do have a slant asymptote. I don't know why I'm abbreviating that. Slant asymptote through y equals x. Okay. So we've established all of our asymptotes, or I should say lack thereof. The only thing we have is literally a slant asymptote at y equals x. Now, what's the domain? Since we have no vertical asymptote, your domain is literally the set of all real numbers. What about your range? It's going to be the same thing. Since we have no horizontal asymptote, you'll have the set of all real numbers. Alright, so that was easy. Now what about intercepts? If you want to find the y-intercept, set x equal to 0, you would get negative 8 over 4, which would give you a y value of negative 2. So the y-intercept will occur at the point 0, negative 2. Alright, so what about your x-intercepts? Set x to the third minus 8 over this x squared plus 4 equal to 0. You just get x to the third minus 8 equals 0. So this would turn into x minus 2 quantity times x squared plus 2x plus 4 equals 0. Well, we know the quadratic factor is not going to have any real solutions, right? It won't have any real solutions. You'll have two imaginary. So just focus on the real piece here, the x minus 2. You get x equals 2, so you have an x-intercept at the point 2, 0. So this one was pretty nice. You had only a slant asymptote. The domain and range were the entire set of real numbers, and you actually had y and x-intercepts. Let's see if we can do one more slant asymptote. Well, it would look like we could, but I'll make up one. Let's see here. Actually, let's do one very similar. Let's change that sign. Let's do the last one here. What if I made this x cubed over 8, x cubed minus 8 over x squared minus 4? Well, that changes everything, doesn't it? That's actually going to change everything. So what we're going to do now is we're going to factor this. If you can factor, you may not have a slant asymptote. You very well may not. But let's go ahead and factor the numerator and denominator. So you'll end up having, let's see, that x to the third minus 8, this would end up turning into x minus 2 quantity times x squared plus 2x plus 4 all over x minus 2 times x plus 2. Alright, well, your x minus 2's do cancel out. This would simplify into x squared plus 2x plus 4 all over x plus 2. Well, you're definitely going to have a vertical asymptote at x equals negative 2, right? There is a vertical asymptote at x equals 2. But we have to also go with the original x minus 2 that factored out. It doesn't mean there's an asymptote there. Whoops, it should be x equals negative 2 is the vertical asymptote. There we go. Now at x equals 2 you have a hole. It's not a whole vertical asymptote, it's just that at x equals 2 there's simply a hole there. Alright, now what about horizontal asymptote? The degree of the numerator still ends up greater than the degree of the denominator, so there's no horizontal asymptote. But what about slant asymptotes? Well, the degree of the numerator is greater than the degree of the denominator by 1 degree, so yes, there is a slant asymptote. Let's do the long division. Take that x squared plus 2x plus 4, divide that by x plus 2. All right, x goes into x squared x times x is x squared. Then x times 2, that is plus 2x. Do some subtraction. You would literally just get a remainder of 4. So you ignore that remainder. You have a slant asymptote in the line y equals x. All right, now let's just deal with the domain. Well, for the domain, we have a hole at x equals 2, a vertical asymptote at -2. So those are the two values of x that will not be accepted. So the domain goes from -infinity to -2 non-inclusive in union with -2 non-inclusive to 2 non-inclusive in union with 2 non-inclusive to infinity non-inclusive. Now what about your range? We have no horizontal asymptote, so your range is actually the set of all real numbers. Last but not least, let's deal with intercepts. Intercepts, so we can even use the factored form. That's going to be when x equals 0. So if you put in 0, you would end up getting 4 over 2. You would end up getting a y-intercept at 0, 2. What about x-intercepts? Well, you're not going to have any x-intercepts because this would leave you with x squared plus 2x plus 4 equals 0. You would have imaginary solutions, but when we go to graph these, we only care about real solutions. So in actuality, we have no x-intercepts. We would if we left it in the original form. Well, no, we really wouldn't, because you have a hole at x equals 2. So that's why you don't have an x-intercept. So that's it for rational functions. Next lesson, we will graph rational functions. So I hope everyone has a great day. Take care.